In this tutorial, you will learn how to use kinematic analysis on your design before it goes to production. BricsCAD allows you to analyze kinematics, compute mass properties to see the center of gravity, make finite element analysis, and so on. During the design of this excavator, it is useful to see how the boom joints move when moving the bucket by using the Move tool. However, there is a problem. The boom moves with the bucket and the joints are static. To fix this, add an assembly joint between the boom and the upper platform. Use a concentric constraint between the cylindrical faces of the hole on the boom and the pin on the platform. Now, when the bucket is moved, the full mechanism will pivot as it moves. What you can see here is called neural kinematics, and in BricsCAD, you can see this in real time. The movement of every element in this boom is driven by hydraulic cylinders, but for them to move with the boom, we need to upgrade them to parametric components. Fix the cylinder with the Fix constraint and set the cylinder rod as a rigid set. Create an offset parameter to parameterize the offset of the piston. Now create a distance constraint between two cylindrical faces on both ends of the cylinder. Set the expression of the constraint to the distance as equal to its current value plus the offset. And now change the offset value. Note that the piston moves. You can also animate this. Update the excavator model's hydraulic cylinders so that all the hydraulic cylinders are parametric. Now link the offset to the two main cylinders, connected to the boom with one global parameter so that they move together. Add coincident constraints to the hydraulic cylinders and pins. Now, when you change the value, you see that the boom moves according to the assembly constraint. Link the offset parameters of the other cylinders. Now, when you change the values of the offset parameters, you see that the boom moves according to the assembly constraint.